Hi everyone. For your remote lesson this week, you will be completing the potential and kinetic energy stations. And so you will have 4 stations that's going to help you understand and explain potential and kinetic energy, understand how they transform in between one another in a system, and then also identify examples of each. Okay? Just a reminder for how to do the stations. Each station you'll click here to go to the station and read the directions and learn. And then you'll always come back here to the main screen, and you'll move your sticker on the place where it says put your sticker here each time you complete it. This last station, challenge it, is optional, so you do not have to do it. But if you have some extra time and you want to challenge, that's a good option for you to do. Okay, so we're going to start with read it. I would just do it in the order that they are listed. So read it's first. So click here to go. Takes you to slide 2. And so read it is 2 different parts. The first part you'll read. And if you need any help reading, you can click on this gray speaker, and it's actually my voice reading to you. I'll show you real quick. Have you ever ridden on a roller coaster? Okay, it's kind of neat, and it might be helpful for some of you. So you'll read this through, and then you're going to answer this one question on the left. And that question is, what is the force that acts upon a roller coaster after it reaches the top of the hill? Is it kinetic energy, mass, potential energy, or gravity? And you will type that answer right here in this blue box. Then you're going to continue to the next page, which is slide 3. And again, you're going to finish reading this text. Um, Again, if you need some help, you can just click on the gray speaker, and my voice will actually read the section for you. Okay? And then you have 2 questions in the second part to answer. The first question says, at which position does the roller coaster have the greatest potential energy? And you will choose between these 4 options. A, at the top of the hill. B, halfway down the hill. C, towards the bottom of the hill. Or D, at the top of a smaller hill. And so you'll write your answer right here in this blue box. Then for question 3, another word for kinetic energy could be blank energy. Is it safe, moving, stored, or potential? And you'll write your answer right here in this box. Please note that all 3 questions can be answered by using the text. So make sure you use the text because that will help you get these answers correct. And everyone should be able to get all 3 correct. Then once you're done answering the 3 questions, that section's complete. You're going to go to the first slide. You're going to remember to move your sticker down. And then you're going to go to the second station, which is research it. Now in research it, you are going to do a PhET simulation. So you'll click on the PhET link. And then reading the directions, it says you're going to go to intro first. So you're going to click on intro. And then you're going to make sure you click this pie chart, okay? And then you're going to drop the skater onto the ramp, and you're going to use this pie chart that's moving to help you answer the first 3 questions. Now, make sure up here, this is the key. So green means kinetic and blue potential. And so you can see that at different points on the ramp, the skater's kinetic and potential energy are changing. Slow motion might be helpful just so that you can see carefully when it has the most potential energy, when it has the most kinetic energy, and so on. Okay? And so then you'll answer these 3 questions, and you'll write the answers on the left side. So question 1 asks, where does the skater have the most potential energy? Question 2 says, where does the skater have the most kinetic energy? And question 3 says, where does the skater have an equal amount of kinetic and potential energy? Again, use the PhET simulation to help you answer these questions. If you do that, you should get the right answers. Then once you're done with that, you're going to continue to the next page. And now you're going to play around with friction. Okay, so you're going to switch to friction. You're going to drop the skater on the ramp and watch their motion. And then you're going to describe what happens to the skater over time. Okay, and then after you answering question 4, you're going to adjust the friction slider. Try adding lots of friction, no friction, and then answer question 5 that talks about what effect friction has on the skater's motion. So again, when you're done, you're going to go down here, you're going to click on friction now. Make sure again you do pie chart. And the first question asks, what happens over time? So you'll put the skater back on and watch what happens over time. As you can see, there's a new energy that's present. And then the second part, you're going to want to make sure you try with lots of friction, with no friction, just to see how friction affects the skater. Okay? Once you're done answering those 2 questions, you're going to continue to the next page. This is the last page of the research it station. And this time you're going to switch to playground in the PhET simulation. You're going to create a track that includes a full loop. And so to create that track, you're going to drag the track pieces on the screen and adjust the angles of the pieces with red dots. So real quick, show you how to do that. So you're on the PhET, you're going to click on playground. This is how you're going to add track. And to change the track up, right, you just move these red dots. Okay, and you can add more, I believe. And so you can add loops. Oops. There we go. Oh, that might have to stay there, and then we have to go. Play with this. As you can see, I need to figure it out too. But once you play with it, and get a nice track, however you want it to be, then you're going to answer the question. And again, make sure there's a full loop. So explain what your track needs in order for your skater to pass around the full loop. So you're going to most likely be putting your skater in the loop and noticing that either the skater can make the loop or can't. And so then you'll want to keep adjusting until you figure that out. Okay. And then to explain what they need in order to pass around the full loop, I challenge you to use the terms kinetic energy and potential energy in your description. Because once the skater starts up high, right, they're going to have potential energy, which will transform into kinetic energy when that skater starts moving. Okay? So once you've finished each of those parts, then you're done with that station now. And so you're going to go back to this section, which I'm going to fix because it doesn't, oh, there we go. And first slide. And then you're going to move the sticker down. Okay. All right. Then you're going to go to the organize it station, which moves you to slide 7. And in this station, you have 8 different examples. And you need to identify whether or not it's an example of kinetic energy, KE, or of potential energy, PE. And as you can see, There's 8 of each, and there's only 8 scenarios, so you will not use all of the labels, okay? So, for instance, the first one says book on a shelf, and so if that's kinetic energy, I'd move the KE to the box, or if it's potential energy, I'd move the PE, okay? And you'll continue to do that for all 8. So this one says book on a shelf, bicycling down a ramp, a meteor entering the atmosphere, a flowing river, stretched out rubber band, skier at the top of a hill, a snowboarder coming down a mountain, and pendulum at its highest point. Now, to help you out real quick, remember kinetic energy is energy of movement. And so when anything's moving, it will have kinetic energy, whereas potential energy is stored energy. All objects have stored energy, and n- they're not necessarily moving yet, right? So that's your hint. Once you have identified each of the 8 scenarios, that's all you have to do for that station. So you'll move your sticker, and then the very last one is assess it. And assess it's going to take you out for a little bit. You're going to complete a Google form based on these stations. This is a must. You must complete this station in order to get any credit. So even if you've done every other station but this one, you will not get credit until you fill out this Google form. And I do encourage you to use what you've learned through the other stations to fill out this form. Okay? So use your resources, use what you've learned, and it should be an easy quiz. After taking the quiz, I want you to check your accuracy right away. So once you completed your quiz, there'll be a button that says View Accuracy. And I want you to look through the questions you got right and the questions you got wrong and read the feedback for each question. The point of this Google form is to identify what you still don't understand and then also help you understand and learn from your mistakes. So, again, if you get something wrong, it's okay, but then read why it's wrong and what the correct answer should have been. Okay? And then once you're done with that, you're going to go back to slide 1, which I'm going to just scroll up, it looks like, and you're going to move your sticker. And once you have all 4 stickers here and you've done all 4 stations, you are good to go. Again, challenge it is optional. You might want to take a look just to see what opportunities there are. And if you do any of those um, stations, any of those activities, please show me by moving that this sticker, this blue rectangle there. Okay? And then at the end, again, just make sure you have completed the Google form and the Assess It station, and you also turn this assignment in. Okay? All right, guys, have a good day. Make me proud and get your work done.